did say I wasn't gonna work on this thing, but I didn't have much sleep for the past 3 nights, so I'm just gonna vibe a little and explore this thing a little bit more. That seems to be a good thing to do when you're super tired. I've opened up the top and I've hooked up my little scope to the master oscillator. And here it is, the output, nice square-ish wave at 315 kilohertz, which is a surprising frequency. I expected it to be 1 megahertz or some division or multiple of 1 megahertz, but yeah, 315. So kind of wondering if this thing is in tune and if that's just the frequency it works with, because that doesn't really coincide with the 5242 top octave generator that's in here. Here's the master oscillator in all its reflection. Hello. It's on the right side. We have the vibrato input going in here. I don't know what kind of input that is yet. I'm gonna find out. And then here is like an oscillator. There's a coil and some capacitors, so it kind of looks like a culprit, I think. This white wire is actually an output of an oscillator that's on here. So I'm gonna need to figure that one out. Let's move this over to this. I was right. It is indeed a vibrato signal, an oscillator signal that goes in there. So that's the vibrato signal, which is looks like a low-pass filtered square wave. So, yep, and it's at a frequency of 8.2 hertz more or less, which is a little bit on the high end for a vibrato. You know, I thought this hole was just construction related stuff, but that hole is right above a trim pot. I wonder if that's maybe to tweak the vibrato? Shall we have a little testy? Well, turns out. So that is indeed the trim pot for the vibrato. Oh, what do you know? So I suppose I could bring that to the front panel. That's really fast. Hello. And here we have the vibrato circuitry. There's our beautiful waveform, and this is the vibrato. So yeah, nothing much special. I'll need to see if I can do some fun things with this circuit. Okay, so I took apart the switch panel some more, because I noticed that this was on here with 4 screws. There's 5 switches and there's space for 7. I already mentioned this before, but now I noticed too. So here's the front panel, and 2 spots, exactly the width of a switch. So yeah, if you cut this out very, very carefully, then you can add 2 more switches on each side. Which would mean I could 3D print one of these suckers. I'll need to do it very, very precisely. Because I don't think I can find these like just lying around somewhere, so I'll have to 3D print them. I think this is the only way I'm going to be able to mod in 2 switches for something. Well, making it look as close as it should be, as close as original as possible. Well, I have 3D printed an extra key, and that is actually very close for something that I eyeballed. Yeah. Okay. Okay, second switch 3D printed. This one didn't get melted by me being an idiot, so yeah, looking good. So I'm gonna paint this one red. Well, what do you know, that actually looks really nice. So these are two new 3D printed switches. Yeah. I'm gonna figure out how to put text here and here, because I do know of one way, and that's to use a laser printer and then to actually print the text in a mirror image and put the paper on this facing down, and then using an iron, you know, for clothes iron, to heat it up, and then the ink will actually transfer onto the surface. And that works really well. I've used that for PCBs a lot. It works great as an edge resist as well. So, and I also use it to silkscreen PCBs, and it was very effective. So I could use a similar technique for this. I just need to find a laser printer. Okay, and this is a rough fit on the organ. Cool. Okay, let's test this puppy. Pretty well. So yeah, I drilled 2 holes and glued 2 thick pieces of this guitar string in there and bent them to the side. And then I put a piece of thick gauge wire also through a hole. That's this wire here, actually, that's just sticking through. And that's the actual, like the spring that is connected to the switch that goes back and forth. And yeah, that connects. That wire connects to the one leg of the variable resistor, the trimmer, for the vibrato speed. And then one connection of the switch is just 2 resistors to make 5.7K resistance to ground, because the trim pot also goes ground. So when you turn the switch on, it effectively creates a lower parallel resistance to the trim pot, thus increasing the frequency of the vibrato. The synth switch has been added, wired up, and now looming the new cable. It's gonna go with the existing loom, because the filter is gonna be inside here, because there's not really any space on this for all that. So I still have a whole mountain of these little plastic separators, so I finally have a use for them, because I can use them to prop up PCBs like this. So I just noticed the fuse was completely corroded, like on the edges. I brushed some of it away, but like 2 whole skirts of corrosion. So I put in a new fuse. Well, I've been probing around a lot, and it's clear that the lower octave of this, which is a brown wire, goes over here and to the rhythm switch, the rhythm on-off switch. Basically what it does, if the rhythm is off, goes to the blue wire and basically connects to the other octaves of the keyboard, which goes to the filters and everything else, these things. When the rhythm is activated, this lowest octave actually doesn't go to the filters anymore. Instead it goes to this orange wire to go somewhere over here and to the output of the rhythm, which of course isn't going through any filters. And now I have the flute turn on. Listen when I turn on the rhythm. Oh hey. So the volume of this is regulated by this too, and also you no longer hear the filters. And there she is. There's the money shot. So that's the filter. Okay, got a breadboard set up with the signal from the octave dividers from the keyboard. And this red wire, this yellow wire goes through the switch here to the output. And then finally we also have power and ground. Okay, it's all hooked up. Well, that is pretty cool. Okay, just a really simple envelope, which is just a resistor and a capacitor. What is this? Right, I soldered together the filter board. And I'm just gonna have a big multi-stage switch on the front panel, so to select between different presets. I think that would be the best idea. So anyways, with this finished, I freed up a lot of space on the breadboard, so this is gonna go away. And then I can start putting together the presets. And the presets will basically entail that I'm gonna have a bunch of CD4051 analog switches to route the various signals to filter and to wave shapers and other things. For example, here we have the input and output of the audio, then 2 connections for the resonance, which is just going to be a resistance, so different resistors that will switch in and out. And here, the white connection here is the cutoff voltage controller. So it is paraphonic, so if I would do a chord, of course it doesn't do anything. Now, the purpose of this first preset is actually to combine it with one of the other voices, preferably the flutes. And let's also put on some vibrato. So you can hear the difference. Synthesizer off. Synthesizer on. Well, I made some presets, so I'm going to unscrew this and I'm going to see if I can make 2 holes for the switches, for the multi-switches. Okay, first knob has been added. Not the kind of knob I wanted to put on there. I need to start shopping because I only have one of these and I need two. And I would prefer to be a tad smaller. Okay, the filter board has been mounted. So there we go. Now here is going to be the presets board. That should about fit here. And if not, I can always put it on the back here. Hey, working on the presets board. I'm gonna have to stuff all this stuff on there. So I have a couple of LM324 buffer op amps, which is going to be 8 buffers, which splits the input signal into 8 outputs, so they can go to the presets. Here's the gating circuit, still a work in progress, but it's coming along. Here will be the 4051s, the 8-channel analog switches. And yeah, and here I'm gonna have to stuff the first 4 presets. I think it will fit, but it will definitely be a very dense board. Well, I just discovered some awesome thing. The top cover actually fits between the gap between this little mounting piece of wood and the back. So you can actually just prop it up like this. This is amazing. I've mounted the presets board, or at least the beginning of it, because it's not entirely finished yet, but I want to design some more presets before I continue on, and I'm eager to test this. So yeah, we got our filter, we got our presets, and then a bunch of wiring that I need to loom. And yeah, I need to stuff a bunch of diodes on here. Something wrong with this, isn't there? I forgot to connect it. Oh wow. Amazing. Okay, well let's wire this up and then let's test if preset 0 works. And if it does, then yeah. So there's only 3 presets now. Although I did design 5 of them. But the remaining 2 presets are solo presets, which I want to put on the last couple of positions of the presets. So I still want to design all the polyphonic presets first. Anyways. So the first preset is just filter just wide open, no filtering whatsoever, just nothing special. Just raw square waves. Now, preset 1 is a stab. These are nice in combination with some vibrato and the flutes. And the next one is like a trill stab. Does still have that issue. There we go. So, I think I'm gonna leave it at that for now. There will be a part 3 in which I'm gonna make some more presets for the treble, and I also still need to make synth presets for the chords. So I want to have some bass lines on this, and maybe some other funky stuff, since this is the rhythm section. So I can do some cool things, like trigger an envelope every time the drums do something. So I can do some really cool things with that. I think it will be cool to have some presets for that. So yeah, we've got a synth sound with 3 presets. We've got vibrato speed, or slow and fast, and yeah, pretty cool. Oh God, oh, that was butchered.